So yesterday we covered a bit of the unit circle in class through Ed Rollo videos when I was away, but I'm just going to spend a bit of time just recapping on the basics of the unit circle. In exercise 14A, you do need to know how to convert between radians and degrees. Oh, what's going on here? Give me a second. Nope. Can you see the laser? Sorry. Can anyone see the? Okay. There must be something wrong. Give me a moment. Okay, that's better. Okay, so in the unit circle, basically what it is that we're still talking about the Cartesian plane here. We're talking about a circle on the Cartesian plane. But there's something special about this circle here. It's called the unit circle for a reason. That's because the radius is equal to 1 in the unit circle. So the distance from here to here is 1. The distance from here to here is also 1. Anywhere from the center to the edge of the circle, that's 1. And you can see here that the coordinates are labeled as well for each of these 4 points because they're easy to measure. Now, when we look at the circumference of the circle as well, we can also look at the circumference of the circle. So the circumference is the length of the entire circle. If we use the circumference equation, that's 2 pi r, we know that the radius is equal to 1 because, again, it's the unit circle. So the entire circumference is 2 pi. Now, this idea of 2 pi here brings about this idea of a new unit of measurement, because from year 7 all the way through to year 10, you've probably learnt about angles as degrees. So whenever you measure something in a circle, you're like, okay, 180 degrees or 360 degrees, right? But now we're actually just going to look at it from radians, okay? From now until university or higher level mathematics, most of the time people look at radians, okay? That's not to say that you won't look at degrees. You'll still use degrees here and there, but most of the time you'll be using radians, okay? So if you don't see, radians has a little C on it, okay? Radians has C, while degrees has a O. Now, the reason why, I'll explain why it uses the letter C. You might wonder, okay, what's the C got to do with anything? Well, we would use this circle if we could, right? But that's already been taken up by degrees, so we can't use that little circle anymore. But what radians are is basically a measurement of the circumference. So if I was to measure just from here to here, that's part of the circumference. So if I was to measure from here to here, that's another part of the circumference. You can see where the C comes from now. Okay. So the radians is basically a section of the circumference. Now, you already know how to use these formulas, write these down, know them well. But if you have a look here, 180 degrees is the same as pi, because we know that the entire circle is 2 pi. So halfway, if we just go halfway, that's half of 2 pi, which is pi. Okay. Now, in the idea of unit circles, and if we start looking at the unit circle, we're really going to touch on fractions in this topic here. We're going to use a lot of fractions. So by the end of this, you'll become really good at drawing circles, and you'll become really good with fractions with the denominators of 2, 3, 4, and 6, okay? Those are the main denominators that we'll be working with, but we'll touch base on that soon, okay? So we have a look at sine, cos, and tan. Now, you've probably seen this way back when you get your scientific calculator, you see these buttons, sine, cos, and tan. And you wonder what they were for, right? What these buttons were for. on your calculator. But now if you actually start looking at these, basically what we're trying to do on the unit circle is that we know that it's still part of the Cartesian plane. It's on a coordinate plane. So notice how we can express it as an X and a Y value. But then, well, what happens now is we introduce an angle, right? So I'll just clear this here. Let's say, for example, I want to find a point on this circle here. I want to find a coordinate. Now, if I was to pick this coordinate here, or this point, that's nice and easy. That's 1, 0. We know what the X value is. It's 1. We know what the Y value is. It's 0. But what happens if I was to find a point, say, right here on the unit circle? Right? How can I find this so I can write this as X and Y? How can I write that as a coordinate? Well, we can't measure that exactly. It's going to be some decimal places, right? But what we can do is introduce something else and start measuring the angle. Now, the angle we usually start measuring from here, the positive x-axis, right? Here's our 0. But you can see from here up until where our point is, we've got an angle now. So we're going to call that angle there theta. So we're introducing a new variable here. We're not going to measure by X and Y anymore. Well, technically we still are, but we're measuring now by what we call an angle, because it's easier to see how much it's pivoting from our baseline. But then, okay, so if we have a look at this line here, from here to here, we can actually break it up into two components, the horizontal component and the vertical component. If we have a look at the horizontal component, we'll call this here the X value, right? And if we have a look at the vertical component, we call this here our Y value. Okay. So we'll get back to this soon. But if you have a look here, the other feature that we know in this unit circle is this length from here to here. It's from the center to the edge. So that's the same as our radius. We're going to call that 1. Okay, so it has a radius of 1. I'm just going to write it in this color here. So now let's say we filter out a few features on here. Let's say I want to find the X. I'm going to scribble this part out so that on our triangle that we only have X and 1 labeled. You can start to see how this comes together if we have our adjacent. Now this is exercise 14D, right? When we covered the idea of SOHCAHTOA. This idea should have been covered back in year 10. So we have our adjacent and our hypotenuse. SOHCAHTOA, we have our A and our H, which is CAH, and that's our cos ratio. So cos equals A over H. You can substitute, what's our A? It's X. What's our H? It's 1. So you can see I've substituted here. And you can finally see that X equals to cos theta. So we have this little summary now that cos measures the X value. Okay, so as long as we have the angle, if we calculate cos, that's going to give us our X value. Okay, and this is important. We're going to constantly come back to this. If we filter out our Y, notice we're not going to look at the X over here. We're just going to look at these two values and the angle. If we filter it out, you'll notice as we go through, we notice we have the opposite and the hypotenuse. We're going to use sine. So sine measures the Y value. You can see the mathematics there come out. If I was to block out one more, in this triangle here, if I was to block out the 1, you'll notice that we'll just focus on Y, X, and the angle. This is our last scenario. And this is this section here. Opposite, adjacent, well, opposite to the angle, adjacent, which is next to the angle. We're going to use TOA, which is tan. Tan is y over x. Now, since it's y over x, we've developed these first two definitions. We can actually draw them in. So what this means now is instead of writing y, we're going to write sine. Instead of writing x, we're going to write cos theta. So this is where one of these little highlighted sections here are really important. Tan theta equals sine over cos, right? So that's equal to tan, right? But what does tan actually measure? This is an equation that you would have came across in chapter 1 and 2, which had an idea with linear graphs. M measures the gradient, okay? So tan theta tells you the gradient, okay? Don't worry about this diagram here. But that's how sine, cos, and tan comes about if we look at the unit circle. So instead of writing x and y now, if we have our angle, we can rewrite x and y. I'll just do it so it's color-coded. We can rewrite x and y as the following. We can write it as cos of theta, because cos measures the x value. And for the y, we can write sine theta instead. Now, when we ask, okay, well, where's tan then? Where does tan come into play? Well, it measures the gradient. So if we have a look at this line here, this line here has an angle, right? An angle or a gradient. So that's what tan theta will tell you. So if I have a flat line, the gradient is 0. If I have a perfectly diagonal line, this is a gradient of 1. We'll cover that again at some point, but this is where sine, cos, and tan come about. Okay, now I'll leave the note like that. At this point in the video, after I do the recording, just pause it and watch it again. Okay, you can write these notes, but I'll also include these screenshots of these notes on Compass as well, so then you can go through and write it down. Okay. The next part, now this is delving into exercise 14E now. Okay, and a bit of 14F, right? I don't teach unit circles in a linear, like alongside with the textbook. It's similar, but I like to go off a bit so that you can actually see what, or explore what the unit circle is about, right? In a bit of a different perspective. So I want to explore the idea of why this section looks like so, right? So let's go through each one. Let's start off with cos, right? What does cos measure? Just someone give it a shout from the classroom. What does cos measure? X. Yep, cos measures the x value. Okay, so the x value, we're focusing on the x-axis here. We know that our highest value is 1. And our lowest value is over here, which is -1. Okay, so we're looking along the x-axis here. If I decide to put a point here, notice on the x-axis, it falls upon the positive part of the x-axis. So you can see if we're calculating cos in the first quadrant here, it's going to be positive. So notice we're putting on a filter for our lens here. What I might do is I might add a new page here. And I might grab this circle. Give me a second. I'm going to create 3 circles because in each of these, we're going to explore sine, cos, and tan. Okay. So cos, that's our x value. All right, let's explore this first. If I pick a point on the unit circle, let's say around here, 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 let's say the first quadrant, right? What we're measuring is the horizontal distance. Okay, so you can see here, if we go across, it's all on the positive x-axis. It's all positive, right? For cos. If we continue around the circle, right, we get up to this point, what's the x value up here? One? Question mark? What's the coordinate? Let's write this coordinate. How do we write this coordinate here? Is it 1, 0 or is it 0, 1? I can't really hear, sorry.
0, 1.
0, 1, okay. Since we're measuring cos, which one are we focusing, 0 or 1?
0.
0, okay. So the x value here, notice it's 0, okay? Same with this point here. This is 1, 0. So cos at this point, you can see it's a positive 1. As soon as we step over into this quadrant though, right, if my points are along this quadrant, like so, what would the values be? Positive or negative?
Negative.
Negative, okay, thank you. So you can have a look here. We're on the negative part of the x-axis. So you can see this is why it's negative. If we stay on this side, notice we're still on the negative part of the x-axis. So down in this quadrant here, it's also going to be negative for cos. But if we start having a look at some points over on this side, if we continue rotating around, and now we pick a point over on this side of this unit circle, you can see it's back to being positive in this quadrant here. Okay, so that's how it behaves for cos, right? This little diagram down here, if you have a look at the purple sections, that's for cos, right? You can see when it's negative, you can see when it's positive. Let's put the filter on now for sine. So sine measures what value? The y value. Fantastic. Okay, so instead of horizontal strokes that we're going to be making, we're going to be making vertical strokes. Let's have a look at this position over here. This is where we start, right? This is at our 0 angle. That coordinate is 0, 1. What are we focusing on this time?
0.
The 0, because that's our y value. Okay, great. So if we start looking at some points along the unit circle, we go around, we start going around like so. If I pick these points in the first half, you can see our lines are vertical. And if they are going up, then what does this mean about the y values?
They'll be positive.
They're positive. Okay, so you can see that in the first 2 quadrants, it's positive in the first quadrant, this section from here to here. And in this section, it's also positive as well. But if we continue around the unit circle, all right, all the way back around, we start going down now. right? So these values here are negative. Last but not least, we're going to cover the idea of tan. What does tan measure? Gradient. Okay, so I'm just going to write M because M stands for the gradient. Now, this one, instead of vertical or horizontal lines, right, we're looking at the angle that the line makes. So if I start here, I'm going to go to the edge, right? But I'm just going to draw for this line here. I'm just going to make it a bit thicker. What is the gradient at this point? Look at this line. It's a flat line, right? What's the gradient there?
0.
0. Okay, 0 for a flat line. What about a vertical line? Undefined. Okay, fantastic. So a vertical line means that we can't really climb it. So it's impossible. Impossible means that it will be undefined. Now, if we start going around the circle, so we're looking at points around the circle like here. If I pick these points from here, 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 if I keep going all the way around the unit circle, I'm going to get to a point where this line here, have a look, it's perfectly diagonal, right? What's the gradient here?
1.
1. Okay, fantastic. And then it's going to become steeper and steeper and steeper until I reach a gradient that is undefined because it's a vertical line, yeah? Now, I'm going to ask you, what happens if we start ticking over to this side now? What do you notice about the gradient?
Negative.
Yes, it's no longer positive. It's now negative. And notice how I draw my lines. I don't draw it from the center out. I always draw the line from left to right. So notice how these are negative. What's the gradient here then? There's a special line here that goes like this.
-1.
-1. Yes. Whoops. As you can see, it's a reflection of this line here. So what I might do is I might make it a little thicker. Okay. If I continue this line now, what's the gradient over here?
0.
Back to 0. Okay. So what do we notice so far? We've got positive. And in this second quadrant here, what's our gradient? They are negative. Let's continue on. We go back around here. And then you notice that the gradient is positive again. Okay, great. Positive. And our final quadrant, negative gradient. Okay, so that's a quick summary of how each of these kind of trig ratios, sine, cos, and tan, work in the unit circle. So here's a little summary then. So I took all of these are positive. So we're going to call this the A quadrant. Okay, because all of them are positive. Have a look here. Do you understand why this is called the S quadrant? Only sine is positive in this quadrant. The third quadrant here, tan is the only one that's positive. And in the last one, you can see that cos is only positive. So there are acronyms for this, but I like to think of it as CAST, right? CAST. So we won't call this quadrant 1, 2, 3, 4. Whoops. Oh my goodness. 1, 2, 3, 4. We're going to refer to them as ASTC. Astica. Yes, I've heard that one before. All stations to city. All students talk crap. Yep. Yeah, but I like to keep it simple. CAST. Yeah, there's a lot of acronyms for it. Like my runners up is this one here. Yeah. So all students talk crap. Or you can just see it as the cast, right? So this is going to be important when we start to find some important values for this. In other words, exact values, okay? So this is all leading up to something where we're building the foundations for understanding the unit circle right now. All right, the next part that we're going to focus on is dividing up this circle now, because I want to have a look at different angles. I got to understand, but I've got to understand where to find these angles. So if I give you, say, for example, 5 pi on 6, you got to know where that lies in the unit circle. Okay. So what we're going to do is we're going to start splitting up this circle into some wedges now. You think of it as like a piece of pie, you start breaking it up into different pieces, right? So exact angles in the unit circle. We'll start off with something real nice and basic. If we have a look at the entire circle here, the easiest thing to do is split it in half, okay? So here we can see this is pi. We start at 0 here, 0 degrees, or basically 0 radians. Now I put degrees there, yeah, for you to make reference. But what I'm really focusing on is radians, okay? So we're going to talk about radians. Just focus your lens on radians. Because once we start dealing with fraction, it's going to be much easier than saying 135 degrees, for example. Okay, so if we have a look here, this is 0, this is halfway. If we go full circle, then we're going to come back around to, it's not pi anymore, it's 2 pi. Okay, so whereabouts is 5 pi located? I would go 1 pi, 2 pi, 3 pi. Okay, so 3 pi is here. 4 pi and 5 pi. It would be located on the left side. Okay, so here would be 5 pi as well. I can rotate in the negative direction as well. So where would negative 3 pi be located? On the left or on the right? Here's negative 1 pi. Here's negative 2 pi. And here is, we're back to negative 3 pi at this point here. Okay, so that's the basic split for this one is basically pi, okay? Now we're going to look at splitting this into quarters. So we're not just splitting it in half. Now, the way that I look at this, right? I'm not saying split in half or split in quarters. Here we're splitting it into 1, right? Focus on the top half here, because if you understand the top half, this is technically 1 piece, okay? Because this is 1 pi. So it's going to look a bit strange, right? You have to kind of redefine your thinking a bit. This section here, we're splitting it into pi on 2. So if you focus on the top section as 1 whole piece, we're only splitting this in half. So if we start counting this, this is 0. If we start going by this much, this is pi on 2. This is pi, which is the same as 2 pi on 2. If we go up to this point here, that's 3 pi on 2. And if we go all the way, this is 2 pi, or how do we express it as a fraction over 2? That would be expressed as 4 pi. All good? Anything lagging? No? Okay, cool. So that's a half, that's a pi on 2 split, right? Here we're just really just getting used to just counting by ones, right? Because if you can count by ones, it'll be a good base to start with. Here we're going to split the top section into how many pieces? 1, 2, 3, 4. So this is counted as 1 pi and 4, 2 pi and 4, 3 pi and 4, 4 pi and 4. If we start continuing now, this section here is 5 pi and 4. So when I say where's 5 pi and 4 located, all you need to do is put a dot in this section here, right? Because I know it's 4 pi and 4 plus an extra pi on 4. Okay. Here's 6 pi on 4. Here's 7 pi on 4. Now, if you have a look at 7 pi on 4 here, that's closer to which side? The left side or the right side? Obviously, the right side. It's closest to 2 pi, which is the same as 8 pi on 4. 7 pi on 4 is the same as 2 pi, but you're just subtracting pi on 4 from there. So you're pivoting backwards. Now, why do I mention this? These 2 points here are going to be very important when we start looking at angles. Okay. So we're still setting it up. In this section here, we're focusing on pi on 3. Because if you have a look at the top half, we're splitting it into 1, 2, 3 pieces. So you can count from there. And you can see 1, 2, 3 pi on 3, 4 pi on 3, 5 pi on 3, and we're back to 6 pi on 3. So that was 0 degrees or 0 radians there. Last but not least, this one looks pretty crazy, but we're just splitting it into the top half into 6 pieces. So we go 1, 2, 3, 4, 5, 6. Okay. And you can see that at some points, this line here, that's 2 pi on 6. That's the same as pi on 3 before. Notice they're the same angles. So you can also simplify. If I pick this line here, that's the same as 4 pi on 3. You can see it's 8 pi on 6. You can simplify it. So this is where fractions, your understanding of fractions really comes into play. Once we get to 6 pi on 6, we can go 7 pi on 6, 8 pi, 9 pi, 10 pi on 6, 11 pi on 6, and then back to 12 pi on 6. Notice that 12 pi on 6 is the same as 2 pi. So once you kind of get used to this now, you probably realize that we have a few denominators that we work with. 1, 2, 3, 4, and 6. And these are what we call our base angles. Okay. We're going to do a bit of an exercise now. The other thing just one more thing before the exercise. If we're pivoting from an odd and even pi, I'm going to talk about odd or even pies just really quickly, but you may have already picked this up. On the left here, we always have odd pies. -3 pi, -pi. That's where this position is always located. On the right-hand side, we have even pies. Remember how before, just a moment ago, I said that these points are going to be very important? These are what I like to call pivot points. We're going to pivot from here to find these other angles up here, like these ones, okay? So in your book, what I'd like you to do is I would like you to draw out a unit circle. Doesn't have to be perfect, just draw it out real quick, 2 lines.